Welcome back, everybody, to Innovation Nation. Today, I have Dave Sterlace with me. Dave, can you please introduce yourself?
Sure. Thanks, Sarah. My name's Dave Sterlace. I'm with ABB. I'm the global head of technology for our data center solutions group, and that encompasses all of what ABB does.
Thank you. I want to jump into it right away, Dave, because when we last talked and we first met, I thought it was really interesting what you did. And so can you please share with the group and those listening what your solutions group does and what type of focus you have when it comes to data centers for
Sure.
technology?
No, absolutely. Yeah. ABB is in case folks aren't familiar with them, we're a Swiss, basically electrical engineering company. We've been around for over 100 years, focused really on electrical infrastructure for data centers. So you won't find us as much in the white space, but more in the what we call the gray space, where you see all the big gray boxes that make the data centers run and keep the equipment up. And that includes everything from utility connection all the way down to the critical power for the servers themselves.
So there's a lot to unpack there. And I personally obviously have tons of questions, as I always do. And data centers are an area of focus for myself, of course, too, with what I do in my job. I've worked with data centers for many, many years. And I'd love to understand kind of how you got into what you're doing. And I know you've been with your company for quite some time now. Can you share with us about, what your journey looked like and how you got to where you are today?
Yeah, absolutely. I've been very fortunate. I've been able to, especially in the last couple of roles, really to chart my own path. But I started as in Silicon Valley as OEM sales engineer, and I worked with all the big technology companies, but mostly semiconductor capital equipment. So folks like Applied Materials and Lam Research that were building the machinery to make the semiconductor chips at the time. And from that, we evolved a little bit, and this was close to 20 years ago, which explains my hair. But we were able to develop into a more those critical processes begat the beginning really of the commercial data center industry. Got involved with that. Of course, Silicon Valley was really the nascence of the whole thing. And I had a background before that of being in emergency power, which was things like generators and automatic transfer switches and things like that. So that was kind of a logical progression. And then as time went by, I got the opportunity to move into more and more progressive roles. In this last one, I kind of charted for myself. So I went from being a kind of a solutions architect type position to being in charge of technology. And in technology, really a great role, and I'm thankful and grateful that I got this, because what we were able to do now is I not only pick what we use from our portfolio, review the portfolio constantly, and it's, as you can imagine, it's a $30 billion company, so there's a tremendous breadth of things of toys to play with, right? But also talk about when we can, certain things like we don't do cooling, we're not really mechanical engineering, so we'll partner with folks, and then also what things we can develop ourselves. So I have an R&D role as well. So really an interesting breadth of a job that's been fascinating. And of course, right now, given the current global situation, data centers are probably more important than ever.
Yeah.
As you'd imagine.
I would love to, well, that's a good point, right? I want to talk about that a little bit. And I'm curious to understand, like, from your perspective, Dave, because you've seen a lot of evolution over the years. I mean, data centers were always kind of like, I feel, not the top of mind, place that we would think about in our daily lives. But what's interesting is a lot of our daily life is powered by data centers.
Absolutely. And
Is that fair to say?
Yeah, no, that's absolutely true. And I think to your point, it was initially a data center was kind of like an accessory for the IT department. It helped run stuff, but they didn't really pay too much attention to it.
Mm-hmm.
As a result, we had the way they were deployed, and they were smaller but have more infrastructure. You had a lot of unused capacity. You'd have 3 or 4 times the load to feed one particular place. It was complicated, expensive, heavy on cost, both initial and operating cost. And as they became bigger, the enterprises started paying attention because it costs so much, and things like cloud compute and other things. First of all, the scale quadrupled, more than that, went through the roof, and we went from the cost per megawatt fell dramatically. You know, it was just a few years ago we were talking about 12-15 million dollars a megawatt. Now we're below 6 in the hyperscale stuff.
Wow.
And the deployments went from, well, at that first number it would take 2 years to build this out. Now it's 6 months. Everything's pre-ordered, pre-staged, pre-assembled, so prefab, modular construction, etc. So it's really changed, and the ramp rate, the acceleration of change is even getting faster now.
So what are some of the things, and you mentioned prefab, which is interesting because I've also seen a lot of that as well, even from like a mechanical side. Like
Yeah.
we were running into a lot of like pre-builds, and where we'd get stuff done like at the factory, and it was a rinse and repeat scenario
Okay.
to make, because at the end of the day, they were looking to make every inch of cost the lowest it can be. So every single thing that had a cost associated, we wanted to find a way to automate,
Yeah.
and make it a lot quicker to do. Because as you know, in construction, we also, budgets and timelines are a really big deal. And data centers, not only is the construction of the buildings themselves expensive, but a lot of the components that you're putting into them are very expensive.
Yes. No, that's exactly right. And I think it's a bit of the maturation of the industry, where we've gone from they were almost, when we go back to what I said earlier about the vanity project or whatever, they were almost, hey, I invented a new way to do this, and this is my topology or whatever, to now it's a business, and it's serious, and we got to get it done. We got to get this deployed. We got to do it fast. Every day we're not open, we're losing money, period. And so it's a completely different mindset, but also a lot more opportunity and a lot more innovation, I think, right now than ever before.
So what are some of the biggest things, if you can share with us, that you've noticed, either that has changed at a more rapid speed lately when it comes to the technology itself? Like if we can get a little bit granular, I'd love to understand, like, what are the trends that you're seeing right now, and what may have used to been a certain way and is now like very much different?
Yeah, I think, and again, I'm in the gray box space, so we'll start with that. But the sustainability aspect is completely, data centers have a target on them. They use a lot of power, and how to do that effectively, how to integrate renewables in that. We've all seen the pledges from Microsoft where they're going carbon negative. They're going to erase their past sins, quote unquote. Google, similar. Amazon as well. Amazon wants to run their whole business, including retail, which is different than what I normally deal with, the web services side. But the retail, the fleet of trucks are actually talking about being carbon neutral on that. So that aspect's tremendous. The topology itself, like I said, we used to have a lot of stranded capacity, a lot of, four circuit breakers to feed one load, each with the full load on it. So you had like 4 times over provision. That's now a lot leaner because of that, because of the sheer scale of things. You're talking 100 plus megawatts, which is the amount of power a small town uses, really. And when you connect that, you have to, obviously that's a big load for the utility company. You have to be involved with them up front. But there's some benefits to that as well. Because of the tremendous power use, it's less likely to go out because of where you connect on the chain. The higher up the chain, the less likely, that a squirrel on a telephone pole or something is gonna mess up your power.
Yeah.
So there's been a lot of innovation in terms of that too. But again, it really comes down to sustainability, being more of a business, and doing things faster. Now doing things faster is, in my view, has never really changed, but it certainly, that pace is ramped up. The acceleration of doing things faster has.
Yeah. And I know for sure now, like, especially with technology, there's so many ways that we can use it to do things faster, right? Like, I think a lot of about, like, the Elon Musks of our world, right?
Yeah.
Who just, it's like you either get with it or let it, it's like you have to either find a way to make technology your friend or it's going to beat you, right? Because the technology is moving so quick now, and I use that. Sometimes I don't like generalizing
Right.
because we break down technology and what that really means. There's so many areas of it, which is part of why I'm so happy I was able to bring you on today, because I love the background that you have and that you bring to the table. It's quite one of which that is not from, my side of the world, which is physical security
Right.
today. We overlap a bit, from when I used to work at Johnson Controls.
Right. We were talking about
Did a
that. Yeah.
lot of work together with ABB, and our components, we would work with your components, and then I know your specific areas more on the electrical side. But it's interesting because for you, Dave, you've done this for a long time and you've seen a lot of evolution, and I'm curious to understand, you mentioned you also have an R&D group. What are some of the methods that you follow when you are given like a new deliverable or a new goal to meet, and you have to find like innovative ways to get there? Like, what are some of the ways that you can like rate technology and decide like, this is something we want to invest in, this is something we believe is going to work? How have you like kept up with everything that's changing so quickly?
Yeah, that's a great question. And where we started is essentially we're looking to make all the components, all the products smart, first of all. So they have to be able to communicate.
Okay.
So around that communication aspect is safety, of course, cyber and physical safety. You don't want people obviously being exposed to danger. The cyber aspect to it, because it communicates, and in order for our stuff to talk to, for example, JCI stuff, it has to communicate digitally, which is a different way. We used to use little wires everywhere. So we're seeing a lot of digital communications. We're
So
using.
can we pause there though?
Yeah, sure.
If you can help, I like, because for those who may not understand where we come from and what that means when we talk digital communication, can we quickly break that down for like the simplest?
Yeah, absolutely.
Thank you.
So, so at well, think of your house, right? At one time, you had a thermostat in a wall. It was off on. It had a little switch in there that turned off and on at a certain time. Now, most houses have some kind of control panel, digital, and if you have, for example, a Nest or something, then you can also program that to operate when you want to. The mere act of putting some brains into that little off on switch changed and made more efficient how you heat your house. It can save you money, etc. It's a great way to do it. So now imagine doing
Great way
that
to
to.
describe it. The way you just broke that down, well done.
Thank you.
No, because I've talked tech with a lot of people, and I've talked with people like yourselves, and I come from it and I'm from that industry. So like I could sit here with you and go on for hours probably, and we'll always understand what we're saying. But
Yeah.
you made it really simple. You're taking a light switch. Let's just talk to that for a sec. You're taking a
Sure.
light switch. We're taking the capability of what it does today, turning something on and off. We're adding brains to it, right? And
Exactly.
then now we're opening a door for ourselves in as simple as your home to do all these different things with a brain, like a brain. And who came up with the term brain? Obviously humans, right? We
Right.
have brains in our minds. Our minds are brains. And so when you think about that, you're using technology. It's almost like the backwards way of doing it. If you think about it, for so many years, or at least as we move forward, like Elon Musk in this world is saying, well, we're going to start putting tech into our brains. Well, we're putting brains into the tech too, as
Yeah.
humans,
Yeah. Exactly. Exactly.
right?
It's kind of
So
funny. Yep.
it's a funny, that kind of dawned on me because we talk about AI a lot too. And like when you're talking about like smart systems talking to each other, that's its own world
Yeah.
that we won't ever be able to quote interact with unless we become the technology ourselves.
Yeah. Well, it's interesting because right now the AI works very well within a limited band, right? So if we have that heating control or that air conditioning control for a data center, and in case the audience doesn't know, the climate control is the second largest load in a data center. First is the IT equipment, then comes the climate control typically. So if we can be more efficient with that, that's a business driver. Like I said before, it's the maturation of the industry. We have to be more efficient with that. We don't want to burn up a lot of extra watts on that side of the house. But if we can be more efficient with that, then we can get some real progress in terms of things. And famously, I know, and I read or heard a blog recently whatever it is from Musk around, you know, the concerns around broad AI, where AI talks to everything and might out within, you know, he thinks in 20-30 year cycles, which are a little beyond, probably beyond my career span. But anyways, some real interesting posits around that. But for the near term, there's going to be tremendous gains in efficiency from that, just by automating that part of it. And
Yeah.
the key to the digital communication is that feedback loop. So I set the thermometer, the temperature, it gets to a point, and then we have that loop where I can regulate the temperature regardless of what happens in the outside world around that. So and then, you know, it's almost like when I was a kid, you know, my dad would run around turning off light switches and stuff. It's daylight, we don't need the lights on, you know, that kind of story almost.
My dad still does that.
It's a dad thing. I do it too.
It's hilarious. So because I come home to my parents sometimes and I walk in their house, I'm like, how is it so hot in this house? Like, what are you guys doing here? And they're like, we don't want to turn the air on. It's going to like make the power bill go up. And I'm like,
Exactly.
you know, there's so many ways that, like, you know, not me being the HVAC girl, like coming from JCI, I'm like, you know, that there's all these different ways that we can tweak and
Exactly.
change to like make you still be able to use your air and not be paying like $1,000 a month, you know, like it's just so funny. And they've had their HVAC system for like, since they bought the house, so 35 plus years. That thing lasted way too long.
Exactly.
It's time for
if you don't turn it on, they last forever, right?
I know, right? Oh, exactly. Yeah, it's crazy to think about that sometimes, you know, because I think like to what you're doing too, and I do want to take some time to also kind of dive really deep into what you're seeing, like with your specific components, because it's so interesting because there's just so many areas of the industry now. And when you take a data center, like you mentioned, like the top, you know, the energy hogs, right? Like the top two, we're talking like the IT racks, right? Or the IT equipment, just anything in there that IT's using. And then you have HVAC to then, which is trying to service that IT equipment, right? Like we have to keep it cool. Computers overheat, heat gets generated, and then we have to cool that. We have to use extra energy to like make that colder, right? And then that takes power.
Right.
And then there's all these things. It's like a domino effect that trickles down that gets affected, right, by that one single environment.
Absolutely.
And so, you know, it's an interesting concept because when we talk to each vertical, every vertical is different, right? You have like healthcare, they have their own like energy hogs. Then you have like data centers, they have their own. You have like commercial real estate and office buildings that has their own thing, right? And every vertical is different. And for you being in the data center vertical, is there anything that you could say first off that like is very specific to that type of vertical that others don't have besides the IT equipment?
Well, yeah, obviously the IT equipment, and the IT equipment is changing. So as we go forward, as we talk about, you know, we talked about AI and stuff, that requires more intense compute than ever before. So when I started, you know, 10 years ago, you know, 15 years ago in this industry, more or less, really concentrating on it full time, we talked about 2-3 kilowatts a rack. Now for AI nodes, machine learning, we're talking about 30, 40, 50 kilowatts per rack. And once you get above 20 or 25, then forced air cooling isn't really an effective way to do it anymore. You'd have to literally have like a turbo fan blowing through there. And I've been to some university places where they do weather forecasting and things where they are still using on a 20 kilowatt rack, they're using forced air, and it's literally a wind tunnel in there. So it's not as good as it could be. So we're going to see a lot of innovation around cooling moving forward. And the funny part for us is, you know, as the electrical guy, it's easier to deal with liquid cooling and pumping. You know, those are very well established technologies, and we borrow from our other sides of the business, from water treatment, from other areas, municipal water, and it's pretty cut and dried in terms of how to do that effectively. So it'll be interesting how to do that. And obviously, water versus liquid. Sorry, there's some thoughts around what type of coolant to use, but the thermal capacity or the heat absorption is I forget how much, but it's 100 times more than air has. So this is really going to be I think the next evolution specifically for those type high performance compute or AI or machine learning type nodes.
And yeah, and I know we like there's a few tangents I keep taking you on, so I apologize, but I get very interested in these topics because
No worries.
we're talking high computing environments, like ones of which that like we really haven't seen before. I think Matrix. Anytime I think you walk into a data center, it's like there's like a separate room that's like this virtual reality room, and it's like everyone, it's interesting because like that movie came out what, like 10, 15 plus 20 years or long time ago. There's a couple Matrix, but
25, I think. Yeah.
very, very old movies. Yeah, like the original. And the concepts that they were coming up with back then, that they were kind of like making up, like with a little bit of truth in them, are starting to get real.
For sure. Yeah. And I'm actually a science fiction fan. So yeah, a lot of the things we see are playing out in real time right in front of our eyes, which is tremendous.
Yeah. And then also what's interesting is, we talk about construction and we talk about building these sustainability. If you can help us understand kind of like the changes you're seeing there. Like I know in our last conversation, we were talking about how the types of wires we're pulling are completely different now. And the way that we're getting everything to communicate is a very different way than we did prior. Like what are some of those big shifts that you're seeing today?
Yeah, and I touched on it before. We're going from copper control wires, which are analog, right, on or off, to can have a not analog to
Binary?
to binary to TCP/IP to something that, and the benefit of a digital signal and using fiber optics is it knows when it's connected wrong. Essentially, that's the first benefit. So it knows where it is versus a copper wire where you have to ring out. They used to call it where an electrician would go and try to trace out problems and things like that. So it's far easier to troubleshoot, and the capacity of the fiber optics is of course many times that. So in our gray boxes, we're able to reduce our wire count sometimes by a little over 90%. So we go from 2,000 wires to 180 in one specific example I'm thinking of.
Wow.
And you can imagine what that does for manufacturing time, for troubleshooting time, and if something goes bump in the night, which you know how things, they always break at 4 o'clock in the morning on a Sunday or something. So it makes it much easier to get things up and running for that and understand what's going on. So that alone, I think folks should really look at these as being, this is significant progress in a really positive way in order to make things happen better and faster for you.
And let's talk a little like on now because we're talking about like nuts and bolts and the guts within and the change there. Like when it comes to the actual users, right, of the space and the quote unquote end users or the operators of the data center, how are you bridging some of those gaps, like between like what's changing in the field and like how the technology is moving so fast? How are you like communicating the vision properly and also like coaching and guiding, with the actual folks that are using the spaces?
Yeah, so the traditionally a data center would have some systems, a UPS system, which is like a battery backup. It'd have, for longer term stuff, it'd have a generator bank or of some sorts, and then it would have the standard electrical system. Now those were able to be combined. But if you went into an operations center, you'd see 3 different laptops on the control panel, and you'd shake the mouse to see which one you were talking to. Now we're able to, with digital communications, kind of bring them all together. We've done a tremendous, and our industry peers are also coming on board. But you're really bridging the gap across from an electrical system, whether any of those subsystems, to a mechanical system, so cooling, whatever, to an IT system, to an entire building management system. We came up with this term called DCIM a few years ago, but it's really evolved into data center automation. And what that gives you is a holistic view, and the holistic view is what's been missing.
Wow. So when you're taking the holistic approach, like, can you help me understand some of the systems you're capturing beyond the gray boxes that you are usually working with?
Well,
or that you're interacting with, I guess?
yeah, so we work with partners. You know, if you want to see uh, computational fluid dynamics, things like that, we can show you where the airflow is going to be with some partners. We can integrate that into our systems. We leave it open to what the client desires. I mean, you might not trust me, you know, to fix your car, but you'll trust me to fix the light switch kind of story with us. So we try to keep all our communications open. We have, you know, we work with different cloud partners. If you want to do analytics, we're not an analytics company per se. We try to make sure that the data, if you had one of our systems, the data is yours. We don't pipe it all back in and keep it and then sell it back to you. The data is yours. So we try to we think the best way to approach it is to keep everything free and open and interactive and communicative. And that's really, I have a corny term. I call that the democratization of data. But I think that
Kind of true though. There's a lot going on right now in this world about data and what people are doing with it, right? And
yeah,
I mean, I work for an artificial intelligence company, and we are, we're in this physical security space where I like to call it, the data collector at the edge
yeah,
is what our device is, but in the best way, right? Like in a way in which we are open. Like we want people to know what's going on in their building. We're not going to hide that from you. We want it to lead to more efficiencies, right, in this world, to make the world a better place, not to manipulate, right? So there's different ways that I think we have to like kind of find that balance in the middle ground. But like when you think vision, you think like end user and users and people who are leading these or actually using these spaces, like they're also not like a pedestrian, right? They're not like the average Joe either. They're very like, I'm sure they're very tech advanced and know what they're talking about, right? Or what they need and what they want. Would you say that your end user is more of a vocal end user generalistically or a visionary? You know what I mean by that, the difference between that?
yeah. I think
Stickler,
no, I think you've touched on something important because we have kind of a variety of customers. So obviously at the hyperscale end, we're not going to teach them anything about data centers for sure. So we tend to go in with here's our industrial experience base. Here's what we did in other process industries. Here's some things you might be able to take advantage of that are already tried and true in whatever in the bauxite industry for 30 years. And so they tend to be more visionary. And then at the other end, we work with some smaller clients and things that are looking to us to really help them. They've identified the issue. Here's what we want to do. We need kind of a prepackaged way to do that. And so we have things to attack that as well.
Yeah.
But the interesting stuff, of course, is when you get the here's a clean sheet of paper. Let's design something. Here's what our goal is. We want you guys to do this much of it. But anyway,
well, that's a good point though. I mean, that is a good point because you have to build complexity, right? So when you get the blank sheet of paper, it's not that easy as some might think. There's a lot that has to go into, I'm sure, planning and early on to make sure that the job is done properly. And with data centers, I mean, I don't know what the statistic is, but if something goes down, obviously, depending on the actual site itself, there's colos, there's data centers, there's, like Digital Realty, for example, they rent out space. But like time is money, right? And like if you have any downtime in that type of building, there are major ramifications for that.
Yeah. When now we're talking about, millions of dollars a minute or whatever. There's two things that stuck out to me. One of the early OCP conferences I went to, I believe it was Christian Bellady from Microsoft was speaking, and he said, given our scale, we can't understand these complicated systems that we grew out of. So scale drives simplicity. So it has to be much more simple, easy to understand than it has been in the past. And then of course the paradigm has also been, in terms of, you mentioned failures, fail small. If you're going to fail small, fail as small as possible. One circuit breaker, for my world, one circuit breaker is 3 servers. I want to lose 3 servers, then 1 rack, then 1 row, then 1 data hall, then 1, we start getting above that, we're in deep deep yogurt, as they say, in terms of problems. But yeah,
I
fail
love
as small as
that.
possible and keep it simple.
I love how you bring those up because it's such a nice way, I feel like, to kind of like bring this conversation full circle, right? Because we did get a little technical and we did talk a little, like high tech. Um, but I think it's interesting. It's a good takeaway because regardless of what industry you're in, right? And it's a great example, Dave, for you. Like I brought you in, I was so excited because I've worked with ABB for many years, and maybe it wasn't like your specific area of the business, but we all come together. Like we're one big family at the end of the day. We have to make these buildings work.
Right.
And you talk partnerships, like regardless of what seat at the table you're sitting in, it has to be a team effort. And one of the biggest things I'm noticing too, and I would agree with you, even though we're on different sides of the table or maybe different seats at the table, as we scale, it needs to be simple. Like that is one of the most, like the best reminders I've heard in a while. Because we're constantly with this tech and AI and all these things that are so smart around us. And it's like, you have to remember that when you're going in with your end user, right? And regardless if you have a blank sheet of paper to start from scratch or you're going in halfway or at the end of a project, you have to remember that not everybody's going to speak the same language, right?
Absolutely.
And we
Absolutely.
have to find ways to bridge those gaps, not just with the end user, but with each other.
Yeah, no, for sure. And
No?
we don't all have the same, level of comfort with the different technologies and things as well. And
Yeah. And
that's
it leads me to my last point I want to make. And just, I want to ask you this question about industry evolution, turnover, getting new people into the industry. I mean, what are some of the ways, because as we evolve, I know there is a generational gap, at least in construction. There absolutely is. And in my industry, specifically physical security, there's a big gap. What's it like for you guys in your industry and what you're seeing, maybe in your data center vertical or in your industry as a whole?
in the data center vertical, I think there's a skills gap for sure. I think that this is the folks that are in it from construction side, to your point, are look more like me than like you, let's say. And there, it's a bit of a, it's an invisible kind of industry. People understand, oh yeah, this all goes through, I have this talks, I don't know how it works, but anyway, there's
The
this,
black magic market, right?
right, exactly. This is a great window. It's not a great computing device. It's not a great storage device. It's not a
Right.
great networking device, but it's at least a window where I can get to all that stuff. And people don't quite understand that. So that coupled with the gray box industry I'm in, again, stodgy kind of manufacturing. We know that Zoom is worth more than in market cap than GM right now, which is astonishing to me.
Crazy.
And good for them, no question. But I think getting folks interested in this in STEM in general, very important. We actually have a program called Lead for early career folks at ABB. And what it is we bring them in from typically from engineering universities, but you have a 2-year stint where you get 4 different assignments. So you can try a little bit of marketing, you try a little bit of manufacturing, you can try a little bit of operations of some sort, you can try a little bit of sales, etc. So there's a real good way to do that. Yeah, I think that I was fortunate this last 6 months. I have a leader, we call them, which. But
Cool.
anyway, she's a recent graduate from Cornell. Happens to be a woman of color that and smart as could be, and doing just great work for us. And her next assignment is going to be in cybersecurity. So
Amazing.
we're trying, but to your point, it's hard to the getting people to stick is tough. We're not Google. We're not as cool as that. So we gotta try and
I hear you. No, I
wave
know.
with kindness.
Well, we had the same thing too at JCI, and like I will say, like I stayed at JCI for like a full 5 years, and like in JCI's terms, like that probably wasn't long enough, right? And I know there was like a path for me from a leadership perspective, but like they spent so much investment early on in my career, like with the training. We had something similar to what you call lead
Okay.
best, and it was building efficiency sales training, but we called them the best students. And so, all the recent college grads go in, and usually from the STEM fields, like science and engineering and all those, and math and whatnot. And, it's interesting. And I think there's not enough of people, I think, from the younger generation. I mean, there's a whole other tangent I can obviously go down, but if we don't have the right people in our industry being like the power and the brains behind a lot of these efforts that we're doing, like Dropbox won't exist. Just saying.
Oh yeah, no question. In fact, I
You know
saw
what
in
I mean?
no, no, I fully agree. In fact, I saw an interesting from one of our senior management team here in the U.S. It said if you don't have a mentor, it was targeted to folks like me. If you don't have a mentor, not mentee, but mentor under 30, you're probably not going to be as effective as you could be.
I love hearing that because it goes both ways, right? And
Yeah, for
at the
sure.
end of the day, it's you coach up, you coach down, and you get
Right.
coached regardless of where it comes from. Um, I think it's a nice note for us to like kind of leave off on. And I think that, for those listening, like Dave, if people wanted to reach out to you or meet you, like what would be the best way? I'm assuming LinkedIn is a good way to connect.
Absolutely. Absolutely.
Yeah.
Love to talk to folks.
Awesome. And I myself also have tons of massive network from Cal Poly. So Dave, if you ever want to dip into that and you guys are looking to find young folks or vice versa, like I'm sure we can always, share the love when it comes to the industry, because I still to this day, like I'm going to leave on this note. I always joke because like I'd have my friends in tech and I was in the construction world early on when I graduated, and my friends would like be playing ping pong and like getting all their meals fed to them. And I'd kind of be like, that's unfair, in my mind, because I'm like paying for my own lunches, like going to construction sites at like 5 a.m. with a hard hat on,
I
like,
was gonna say you got the boots and the hat,
clearly,
right?
and like, the Bay Area, like I was in the, the Bay for 5 years, and it's
Yeah.
like, do they realize that like they wouldn't have that building if it wasn't for me? Like, and
Exactly.
it's just so funny because it really truly is somewhat of an invisible industry. And I think it's interesting, and I think it's good to have people like yourselves on this, right? Because our typical listener aren't the folks that might be exposed to on a daily basis. So I'm happy that you joined me, and I'm really glad you're able to come on and spend this time with me to help others learn about what you're doing and kind of the technology that we have out there that goes far beyond the physical security space. So I really appreciate it.
Well, thank you, Sarah. I really appreciate your time as well. And it's been a tremendous conversation. Really enjoyed
Thank
it.
you.
Thanks.
And for those listening, please add Dave. We're going to tag him in the post. And Dave, I'm sure you'll probably get a couple ads on LinkedIn after this. So let me know, and hopefully we'll have you back on in a couple weeks.
Great. Thank you.
Thank you so much. Have a good one.